Hey everybody, hope you're all doing well and weathering the storm okay. Hope that you're all safe, and if you're getting this, I assume you're doing okay. Listen, I just want to be able to close out the last section of Chapter 3, which is about polygons. You were supposed to have done a video lesson on Moodle that kind of explained what a convex polygon was and some definitions there. And this is the second half of that section that talks about how we can create some triangles within Polygon to figure out how many angles, and what's the measure of all the angles inside the polygon. But before we do that, just a quick review of some words. Equiangular. You know that equiangular means that each vertex of the triangle has the same measure. So in a polygon, an equiangular polygon is each vertex of the polygon has the same angle measure. Equilateral, lateral meaning side, means each side has the same length. And regular means that it is both equilateral and equiangular. So each angle is the same measure and each side has the same length. So here we have some pictures. If you notice in the top left, we have a quadrilateral with 4 congruent sides, so we call it equilateral. Where over here, the sides are not congruent. You notice the bottom and the top are longer than the sides, but each angle appears to be 90. So we're going to call it 90 and say this is equiangular. And then here we have regular. So we have a 1, 2, 3, 4, 5-sided figure, where if it's regular, we assume that this angle, this angle, this angle, this angle, and this angle all are the same measure, and each side is congruent as well. So if we wanted, we can mark that up nicely, right? We'd mark each side congruent and each angle congruent. And we can say the same thing for the second shape, an octagon, where each angle has the same measure and each side has the same measure, etc. Alright everybody, so here we are again. We're going to look at this triangle and remind ourselves that from Euclid's parallel postulate we were able to prove that the sum of the interior angles of a triangle is 180 degrees. So the triangle, we have 3 sides. We have one triangle. We have 180 degrees. So now we're going to look at what happens when we take a quadrilateral. Okay. One of the things in your textbook that is discussed is diagonals. And a diagonal connects one vertex to another vertex in a polygon, but a non-consecutive vertex. If we connected this vertex to this vertex, we would be creating the side. So when we talk about a diagonal, we're talking about a vertex and a non-consecutive side. So we have to skip one of the non-consecutive vertex. We have to skip a vertex and go to the next one. And then the next vertex is also consecutive. So there's only one diagonal in this triangle, in this polygon. We only draw diagonals from one vertex at a time. So when we do that, we see we have 2 triangles. And again, we know we have 180 degrees and 180 degrees. And you can add these up, all these measures, and you'll see that we have a 4-sided figure. We have 2 triangles, and we have 360 degrees. So why don't you go ahead and try this now with a 5-sided figure or a pentagon, and then I'll do that on the next slide as well. But you give it a shot yourself. So here we have a 5-sided figure. Hopefully you can pick a vertex and draw diagonals to non-consecutive vertices, and then you can see that we have 3 triangles. So we have 5 sides, 3 triangles, and we have 3 times 180, or 540 degrees. So the question is, what if we had n sides, meaning any number of sides. Well, what do you think the pattern would be? When we had 5 sides, we had 3 triangles. When we had 4 sides, we had 2 triangles. So what do you think we'd have when we have n sides? Well, hopefully if you kept doing this for a while, you'd start to guess that when we have n sides, we're going to have n minus 2 triangles. And then to figure out the measure of total, we'd take 180 for each triangle times the number of triangles. And that equals the sum of the interior angles. And that's actually a theorem for this chapter. What is the sum of the measures of the interior angles of a polygon? It's 180 times n minus 2, where n equals the number of sides of the polygon. So let's look at an example here. We don't even have to be able to draw the picture. If we're asked to find the sum of the measures of the interior angles of a 10-sided polygon, or a decagon. So we know it's 10-sided, so n equals the number of sides equals 10. And the interior angle sum equals n minus 2 times 180. So this is just 8 times 180, or 1440. Okay, so there are some other examples that come out of some questions that we can ask here, but we'll look at them in a minute. The other thing we need is, what about the exterior angles? So if you recall, in a triangle, the exterior angle is what you get when you extend one side, right? So, and if you added each of these, the question is, what would that equal? And similarly, if you had a pentagon and you had an exterior angle, 1 at each vertex, what would that be? X plus y plus z plus w plus v. Well, it turns out that for any polygon, if you add up all the exterior angles, 1 at each side, 1 at each vertex, only 1, you don't want to do doubles. If you only have 1, it turns out that the sum of the measures of the exterior angles of any polygon is 360 degrees. So they will always equal 360 for both. So that's another one of your theorems. We don't bother proving it, but we can use it when we get to a specific kind of problem. So we're going to look at that next. Alright folks, so we're going to try and look at some problems here dealing specifically with regular polygons, meaning polygons which are equiangular, each measure of each angle is the same, and equilateral, each side has the same length. So let's try, I'm going to try and draw a hexagon that's regular. Not too smooth, but you get the idea. So assume this is a regular hexagon. Okay, so that means that each of these angles is congruent, even though it doesn't look like it, but we don't go by looks, we know that. Alright, so you know that your angle sum, interior angle sum, equals n minus 2 times 180, or in this case 4 times 180, or 720. So that means that each angle is 1/6 of 720, since there are 6 angles, or 120. Alright, so that's a pretty typical problem. What's the angle measure for each interior angle? And then you can figure out pretty easily what the exterior angle would be, because if you know this is 120, and you know this has to make up 180, then each exterior angle will be 60. And just as a check, 60 times 6 equals 360, which matches what we said we should have. The sum of the exterior angles should be 360. Now sometimes there'll be an easier way to do this problem, so let's look at some sample problems on the next slide. Alright folks, let's look at some typical questions that you could get regarding this. And those of you that miss algebra should be really happy right now. If you're looking in your textbook, if you happen to have it home, page 104, number 8, asks you to find the measure of each exterior angle and each interior angle if you know you have a regular polygon with 15 sides. So if you have a regular polygon with 15 sides, I don't try to draw it. I just kind of draw what I consider the bottom might look like, and then I figure it just keeps going in all sorts of directions. And what I'm really concerned about is these two angles, x and y, because they're asking for the exterior x and the interior y. Well, remember, just to gather all our information, we know n minus 2 times 180 equals the sum of the interior angles, right? Or n times y. And we know that 360 equals the sum of the exterior. So I think it's easiest to take 360 and divide it by 15, and that's going to give me x. Now why is that? If there are 15 sides, each exterior angle has to have the same measure. They're all congruent, so those 15 exterior angles have to share those 360 degrees. So we know, in this case, x has to equal 24. Now how is that helpful? Well, if we know x is 24, then it's really easy to figure out y, because we know x plus y has to equal 180, because they're a linear pair. So at x, we just figured out to be 24, so y equals 180 minus 24, or 156, right? So each interior angle is 156, each exterior angle is 24. Done. So let's look at another one in that section. Alright, so the same page, page 104, number 8. Now this is part of that table. Now you'll see that we're looking at, all we know is that each exterior angle has a measure of 6. So again, as we draw this thing, the exterior angle is 6. And they're asking us, what is n? And what's the measure of each interior angle, or y? Well, we know that y is going to equal 180 minus 6, or y equals 174, correct? So each interior angle is 174, so this is really wide, so it probably has a lot of sides. Well, how many sides? Well, we know 360 divided by the number of sides has to equal 6, right? Or 6 times the number of sides has to equal 360, because each exterior angle is 6, and there's 1 at every vertex, and there are n vertices. So n has to equal 60. So this is a 60-sided figure. 60 sides. So that's why those interior angles are so open and so wide, right? Alrighty, so I think you get the idea. So for me personally, I don't even like using the n minus 2 times 180. I think it's just easier to kind of work off a linear pair like this. Alright, let's look at the next one. Alright, so now we're going to look at page 105, number 16. It's a word problem, and it says, the sum of the measures of the interior angles of a polygon is 5 times the sum of the measures of its exterior angles, one angle at each vertex. How many sides does the polygon have? Now in this case, they're not telling us that it's a regular polygon, but I don't know if it matters. So let's look at what it says. The sum of the measures of the interior angles of a polygon. Sum of the measures of the interior angles is n times 2 times 180, where let n equal the number of sides, which is what we're looking for anyway, so that seems to be a good variable. Is equals 5 times the sum of the measures of its exterior angles. So 5 times the sum of the exterior angles, which we know is 360. So I think that equation fits. The sum of the measures of the interior angles of a polygon, n minus 2 times 180, is 5 times the sum of the measures of its exterior angles. And we work that out, and we can figure out what n is. And I think I leave that to you guys. Alright guys, so I'm going to leave you some homework to do based on this lesson and the lesson that you watched over the break. And I'm also going to give you a couple review problems from the chapter to get you ready for the test. And I'm going to post some always, sometimes, nevers on this chapter. So between this section, reviewing for the test, and reviewing always, sometimes, nevers, I've moved your test to, it was on Monday, but now I've moved it to Thursday. I think that's November 8th. So, yeah, Thursday the 8th. So your test is going to be on Thursday the 8th. I hope to start a little bit of Chapter 4 when you guys come back, but we also have proofs to go over. I may even post another video about proofs, so we'll get everything going for you guys. Have a good weekend. Good luck getting your work done, and we'll see you guys soon.